Okay, this is TwoSum. So in TwoSum, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. Okay. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. All right. 2, 7, 11, 15. In the first example, the target equals 9, so obviously it would be 2 and 7. Um, and then output 0, 1, because those are the indices of the two numbers that add up to the target. Because nums 0, unless nums sub 1 equals 9, we return, yeah, okay. Oh, my bad. Whoops. Um, all right, and in the constraints, only one valid answer exists. The nums can be length of 2 to 10 to the 4, and num can be anywhere from negative 10 to the ninth power to 10 to the ninth power, and target can be anywhere from negative 10 to the ninth power to, okay. All right. Can you come up with an algorithm that is less than n squared in time complexity? So I assume the n squared, just from thinking about it, um, n squared would be if you, for each number 2, you try to add up 7, 11, 15, um, just each one until you hit the target. And in the worst case scenario, you're gonna do n times for each. Um, uh, Basically, you're gonna add up the whole set of numbers, uh, and you get all the way to the end. So that would essentially be n times n, which is n squared, time complexity. Technically, it would be 1/2, because as you get to the end, there would be no need to add up. Well, no, it would be n squared because we're not guaranteed that this is going to be sorted, so you have to add up each one. So, yeah, so it would be n squared. So, okay, how do we do one that's less than n squared time complexity? Okay, so what we want to do first um, is we want to, I think what we're going to do is probably employ a hash map. So we go hash map equals that. Or we could say it's scene equals the hash map. Um, yeah, and in this hash map, so we create a hash map, and then what we're going to do is if whatever we add, whatever number we're on as we loop through the array or the list, um, and for whatever number we're on, calculate the complement, which is going to be how much it needs to be to equal the target, and if the complement isn't in the hash map, then we're going to store the complement and index and move on. If it is, then return the indices, and that should do it. That should do it. All right, so scene equals a hash map, or a dict, and for I in range nums len nums, um, complement equals target minus nums sub I. If complement in scene, return nums, it's going to be index, so it's going to be return I and scene complement, which should be the index, right? Because there's only one solution. Else, if it's not in scene, then we're going to store it. So scene complement equals what would be the scene complement? No. If complement in scene complement, no, okay, no, yeah. So we store the complement, or actually we just store it, we have to store the number equals I. Yeah. And then going to return, and there's no other solution, so we're gonna let's try it. Okay, so in a problem, if we have a test case, so 2, 7, 2, 7, 11, 15, the first number is going to be 0, so it's going to be 2. So the complement first num2 or num sub I is going to be 2, and then complement is going to be complement is going to equals target 9 minus 2, so is the 7. Complement is 7. Okay. Now, if the complement is in scene, which it's not, yeah, and then else, so we're in the else block. Scene num sub I, which is 2, equals I, which is 0. Now on the next iteration, we're going to have 2, we're going to be on 7. So 7 num sub I equals 7, and the complement is 2. 2. Scene, now, is the complement in scene? It should be. Because scene 2, yeah, so 2 equals I, so we're going to return I, so the current I we're on is 1, and then we're going to return 0. And that should be the problem. Yes.